Welcome back, everybody, to A-level mathematics. Today I'll be doing binomial, arithmetic, and geometric series. Let's get started. So first of all, what is an arithmetic progression? So 1, 3, 5, 7, 9, and 11 are as an example of arithmetic progression. They all increase by a value of 2, so the increments are plus 2. And it's usually represented in this form, Tn, which is term, and nth term. This refers to nth term, a plus n minus 1 d. A is the starting term. In this case, the starting term is 1, and d is the increment value, so it should be a. So if in this case, it should be 1 plus n minus 1 multiplied by 2, and d is equal to 2. So the sum up until the nth term, so it could be from the first term all the way to the fifth term, so it'll be S5. So sum up until the nth term is represented by these formulas, where it's n multiplied by the first term plus the nth term over 2, or it's n multiplied by 2a, which is the first 2 times first a, plus n minus 1 d over 2. These are basically the same thing. This format is just the expanded version of this. Next up, we have a geometric sequence. An example is 1, 10, 100, 1000, or 10, 5, and 5 over 2. So it's an increase or decrease by a factor. In this case, it's increased by a factor of 10. And in this case, it's decreasing by a factor of 2. So you divide by 2, you divide by 2. And it's represented in this form, where the nth term is equal to a multiplied by r raised to the power n minus 1. So a again refers to the first term. In this case, it could be 1 or 10. R refers to the factor. So in case of this progression over here, r is equal to 10. And in case of this progression over here, r is equal to half because it's decreasing or divided by 2. So sum up until the nth value is represented by these formula. A minus ar, a multiplied by r raised to the power n plus 1 over 1 minus r. And that's the sum up until the nth value, where r equals to, and in the sum, for the sum formula, when r is equal to 1, 1 minus r, or the denominator is equal to 0, and the equation is undefined. So there cannot be a sum if r is equal to 1. However, when r is less than 1, but more than 0, as n approaches infinity, ar over n plus 1 approaches 0. So, for example, if you raise 0.5 to the 1000, the value approaches 0, and you keep increasing the value of n. R will become smaller and smaller until r is approximately 0. And you can, to estimate the sum, you can substitute 0 in the place of a r raised to the power n plus 1, which will give you a finite value. And this shows that the series converges to a point. However, when r is more than 1, as n approaches infinity, ar raised to the power n plus 1 becomes extremely large, and the series diverges. Take note that in the form, when you're finding the nth term, it's n minus 1, and when you're finding the sum until the nth value, it's n plus 1. Again, check your data booklets. There's really no need to memorize these formulas, except this one maybe, and the sum. They may not be given in your data booklet, but they might be given, so just check your respective data booklets. The binomial series is when it's a plus b raised to the power n. This is a form where you recognize it. In these cases, for arithmetic progression, they will usually tell you, or you will know because it's a constant increment. So if there's always an increase of 2 and it's constant, it's probably arithmetic. However, if there's an increase or decrease by a factor, for example, interest over the years, or there could be a decay in cost. Like, for example, they say that the price of your car has depreciated in value by 30% every 10 years or so. That's a geometric sequence because it follows a factor. So that's how you can recognize the sequences in your examinations. For binomial series, it's pretty obvious because it will be a plus b, where a and b are two polynomials, or they contain x values, or they may not contain x values too. And where n is usually more than 2, and a and b contain x values, like I said. So just for a quick understanding purpose, number of values in a series, or when you expand this out, how many individual values you will get. For example, when you expand a plus b raised to the power 2, you get a squared plus 2ab plus b squared. Because n is equal to 2, n plus 1 will give you 3. So when you expand something, when you expand and anything raised to the power n, you get the number of values in the series is n plus 1. So when n equals to 3, for example, it's a plus b raised to the power 3, there'll be 4 expanded values. Next up, this is your binomial formula. You could memorize this as such, or I could teach you another way for you to know that when I go through the questions later on. But this is given in your data booklet, so you don't really need to memorize any of these formulas. Just take note of this formula. This is quite special. You might be asked to represent your answers in terms of n, and this would be useful when expanding 5 choose 1 or n choose 1. You can use this formula. So let's start with some questions. The sum of the first 9 terms of an arithmetic progression, the question tells you it's arithmetic, is 117. And the sum of the next 4 terms is 91. So sum up until the 9th term is 117. And using this formula over here, I expanded to give me n 2a plus n minus 1d over 2 equals to 117. I use this formula because we don't know the first term and we don't know the increment value. So you're probably going to require to do simultaneous equations, and you need both both unknowns in your equation. So simplifying this from expanding the formula out, multiplying by 2, dividing by 9, get 2a plus 8d equals to 26, and you divide by 2 throughout. Should give you a plus 4d equals to 13. I'll label that as equation number 1. Next up, if the question says that the sum of the next 4 terms is equal to 91. So from term number 9 to term number 13, the sum is 91. So using the sum of the first 9 terms and the sum of the next 4 terms, we get sum up until the 13th term, which is 117 plus 91. Which will give you 208. Using the same formula as before, while maintaining the 2 unknowns a and d, we can simplify the equation to a plus 6d equals to 16. And then taking equation 2 minus equation 1 gives us 2d and equals to 3, and d is 1.5. Substitute d back into equation 1 or equation 2, and you get a equals to 7. And that's how you find the first term and the common difference of the progression. Next up, we have binomial expansion. So you have to find the coefficient of 1 over x in the expansion of kx plus 1 over x raised to the power 5 plus 1 minus 2 over x raised to the power 8 is equal to 74. They tell you that the coefficient is equal to 74, and you have to find the positive constant k. So like I told you, you could memorize this formula, or you could memorize the formula that I'm going to teach. In this case, you write down your binomial expression over here, and then you expand it in terms of r. Okay, r can be any value, and you can find r can be any value. So first things first, it's 5 choose r multiplied by kx raised to the power 5 minus r. Or in this case, if 5 was n, it would be n minus r, and x raised to the power -1 multiplied raised to the power of r. You could put 1 over x, but I like to put it in terms of indices, so I can simplify the indices in the next. As I simplify it, I can eventually separate the x values or the unknown values out and k values to one side, the constant values to one side. So 5 choose r and k raised to the power 5 minus r. Those are constant values; they don't change. However, x values can change. So I move all the x to one side. So it's 5 choose r multiplied by k 5 minus r and x raised to the power 5 minus 2r. This is the general formula for any value in the binomial expression. Now we need to find x raised to the power -1. And we know the indices of x raised to the power -1 is -1. And we equate that to this power over here, to -1 equals to 5 minus 2r. And simplifying this, we find that when r is equals to 3, look, you can find the coefficient of 1 over x, so x raised to the power -1. And then substituting r equals to 3 into this equation, we can find the coefficient of 1 over x, which is 5 choose 3 raised to the power k multiplied by k raised to the power 5 minus 3, which is 2, so you get 10k squared. That's for the first expression. And for the next expression, we do the same thing. We represent the binomial expression in terms of r. So 8 choose r, 1 raised to the power 8 minus 3. And then I split negative 2 over x into negative 2x raised to the power r and x minus 1 raised to the power of r. I do this because, like I said, I want to separate the x values and the constant values to one side. And anything, 1 raised to the power of anything is always 1. So you can negate that from your r formula, like I've mentioned over here. 8 choose r. So this is simplified to 8 choose r multiplied by negative 2 raised to the power r and x raised to the power of negative r. Now we know that we need to find 1 over x. So the power of x is negative 1, and we equate that to negative r. So we can find out that when r is equal to 1, for this binomial expression, it's the coefficient of 1 over x is 8 choose 1 multiplied by negative 2 raised to the power 1, which is negative 16. Now we know that these two binomial expressions are added up because of the plus sign. So the combined coefficient is 74, and 10k squared plus negative 16 will give us 74. Simplifying the equation gives us k squared equals to 9, and it's k is equals to 3 because they're asking for the positive constant of k. We have another situation for binomial expansion in this case. So we have to find the coefficient of x squared in the expansion of x minus 2 over x raised to the power 6. So similarly, I did the same thing like I did before, express this in the form of r. So 6 choose r gives us x raised to the power 6 minus r, negative 2 raised to the power r, x raised to the power negative r. Again, separate your x's and constant values aside. So you get 6 choose r multiplied by negative 2 raised to the power r. And combining these two powers, because it's multiplied, using indices rules, you get 6 minus 2r. Now we're finding the coefficient of x raised to the power 2. So 6 minus 2r is equal to 2. So r is equal to 2. So when r is equal to 2, you get the value of x squared. So the coefficient of x squared, by substituting r is equal to 2 into this formula, gives us 6 choose 2 multiplied by negative 2 raised to the power 2, which gives us 60. Next up, we have to find the coefficient of x squared in the expansion of 2 plus x, 3x squared. So first things first, write out your equation that you have to multiply throughout. And then now you have to find the coefficient of x squared. So what gives us a coefficient of x squared? Because 2 is, when this is independent of x, so 2 multiplied by x squared will give us an x squared term, and 3x squared multiplied by a value independent of x will give us another x squared term. So we already found the x squared term for in this case. So now we have to find the x independent value when x raised to the power 0. So 0 equals to 6 minus 2, 3 from this equation. And when r is equal to 3, we can find the x independent value, which is 6 choose 3 multiplied by negative 2 raised to the power 3, which gives us negative 160. And now we have to find the coefficient of x squared. So we know that 2 multiplied by x squared, so it's 2 times 60. And we know that 3 multiplied by the x independent value, so it's 160, negative 160 times 3, which gives us an overall value of negative 360. We have another binomial expansion. Again, you can use the formula from beforehand, in this case, to memorize it, or you can write it out like how I've written it out. So they're asking you to find the ascending powers of a up to the value a raised to the power 3 or a cubed. So you just simply write out the equation. So we have 5 choose 0 multiplied by 1 raised to the power 5 multiplied by a raised to the power 0. And then it continues 5 choose 1, 1 raised to the power 4, a raised to the power 1. 5 choose 2, 5 choose 2, 1 raised to the power 3, a raised to the power 2, and so on. It's basically the r formula expanded for each and individual value. So in this case, r equals to 0, r equals to 1, r equals to 2, r equals to 3. Next up, they say that hence expand 1 plus x, or parentheses x plus x squared, square brackets raised to the power 5 in ascending orders up to x raised to the power 3. So we just let x plus x squared equals to a, and using this equation, we just substitute x plus x squared in the position of a and expand it, and you can simplify, and they're only asking you up until a term of x cubed. So you will just expand it, simplify, you'll get 1 plus 5x plus 15x squared plus 30x cubed. I'll just let this be there for a second so you guys can take a look at it and understand what I've done. Or you could just pause the video and take a look at my working. All right, moving on. So they say that, the first term of a progression is sine square or theta, where theta is more than 0 and less than pi over 2. The second term of the progression is sine square theta multiplied by cosine square theta. Given that the progression is geometric, find this sum to infinity. First things first, write out your terms, and then you make it fit the form that has been given to us. So it's geometric, so it's a times r raised to the power n minus 1. In this case, it's the term has been multiplied by a factor of cosine square. So it's sine square multiplied by cosine square theta, or raised to the power raised to the power n minus 1. And now we use the s as a sum formula, which can be simplified by, which is written as sine square theta minus sine square theta multiplied by cosine square theta raised to the power n minus 1. This is supposed to be n plus 1. Or when sine square, you can factorize sine square theta out, which will give us 1 minus cosine square theta raised to the power n plus 1. It's supposed to be plus. And then 1 minus cosine square theta can be simplified to sine square theta using the trigonometric expressions. And then you can simplify to 1 minus cosine square theta raised to the power n plus 1. And as we know, as n approaches infinity, cosine square is approximately 0. We know that because cosine square theta in between this range is from 0 to 1, and with that 1 minus 0, so the sum to infinity is 1, and it converges. It is now given that the previous series is now arithmetic. Find the common difference in the progression in terms of sine theta. Again, write out your terms, and using this formula over here, using this formula, we can equate the two equations. So we know that sine square theta cosine square theta is equal to sine square theta, which is the first term, plus 2 minus 1d. So we have to find the common difference first. Simplifying this, 2 minus 1 gives us just d, and bringing the sine square to the other side and factorize, and using cosine square theta equals to 1 minus sine square theta expression, we can expand this out to give us sine square theta minus sine raised to the power 4 theta minus sine square theta, which will just give us negative sine theta raised to the power 4. It's quite simple. Usually it's just application of formula. So as long as you understand the formula and you write out the terms and you're clear with what you're doing, it won't be difficult. It's the same for binomial. You just have to know the formulas and you have to understand what you're doing. So like I said, this XR formula is used for individual values, and you can also expand it completely to find the answer. This just saves your time, and simplifying it and removing the x to one side and the common values, constant values to one side reduces your chances of error. Similar in this case, you write out what you're doing so that you know clearly that you don't make mistakes, and you can always check your answers. It's the same in this. Since it's plus, you just have to write combined coefficients so that you don't confuse yourself in your examinations. With series, it's common to make mistakes because in binomial there are so many calculations taking place. For example, in this case, it's easy to make mistakes, so you just have to be systematic with your working. All right, so moving on, find the sum of the first 16 terms when theta is equal to pi over 3. So again, we're given, using the common difference from the previous part of the question, we substitute theta equal to pi over 3 into the equation. We simplify it. So we get 3 over 4 plus n minus 1 negative 9 over 16. So we know that term 1 is 3 over 4 when n is equal to 1. And we find the 16th term by substituting n equals to 16, which gives us negative 1, 2, 3 over 16. And using first term plus last term divided by 2 multiplied by 16, we can get negative 55 over 2. And by that, we have come to the end of series. I hope you guys have understood clearly how to use the binomial formula, how to use the sum equation, and for geometric sequence, for arithmetic sequence, and for binomial series. If you have any confusions or any doubts, please leave them in the comment section. Please like and share this video with your friends if you understood it. If you have any suggestions, leave them in the comment section, and you want me to cover any more questions on binomial series or arithmetic series, please let me know. I'll try my best to upload more videos. Stay up. Please check out the other videos in this channel, and it would be much appreciated if you could leave this video a like. Thank you so much, and goodbye.